Hi guys, and welcome back to Physics Solution. And I'm super excited to have you back with me here. Today we'll be solving another question on the topic measurement of heat energy. And the question goes thus: calculate the final or equilibrium temperature of the mixture of 250 grams of water at 65 degrees Celsius when it's added to 150 grams of colder water at 5 degrees Celsius. 5 degrees Celsius. Neglect heat absorbed by the surrounding, and we are given the SHC of water to be 4,200 joules per kilogram per Kelvin. And the first thing we'll be doing right now is to bring our parameters. So this question, first of all, is a question under the method of mixture. So we are mixing two kinds of water together, a hot one and a cold one. So let me arrange this properly for you. Let's say we are starting with the hot water. So let's say our hot water. The water that has the highest temperature is the hot one, while the one with the lower temperature is the cold one. So as you can see, so we're told that a mixture of 250 grams of water at 65 degrees Celsius, definitely that will be our hot water. So the mass here is 250 grams. So we'll convert it to kilogram by dividing by 1000. This will give us 0.25 kilogram. So the temperature is 65 degrees Celsius. And for our cold water now, our cold water the mass is 150 gram. Convert it to kilogram, you'll be having 0.15 kilogram. And the temperature is 5 degrees Celsius. So we're to find the final temperature of the mixture. As we know that after mixing the both water together and you stir it evenly, the water will arrive at a new temperature. Just as we have it when you are about bathing in the bathroom during harmattan period and you boil your water. When you mix the hot water and the cold water together, what will happen? The water will arrive at a new temperature lower than the one you boil and higher than the initial water you have in your bathroom. So that temperature that we will be arriving at after mixing both hot water and the cold one together is our final temperature. We have our theta 2 for the mixture, theta 2 for the mixture. So these values will be the same thing because the two waters are not together now. So they will have the same value of what? Final temperature. So let me show you something now. Something like this, where you have your cold water here, cold water, then you have hot water, right? The cold water here, has theta 1 of 5 degrees Celsius, while the hot water here has theta 1 of 65 degrees Celsius. Now after you mix both together now, when you mix both together, so this plus this will equals to, when you mix both together now, you will now arrive at a new temperature. You have your cool water and you have your hot water. You now have a new what? A new temperature, which you call the theta 2 of the mixture, because we have mixed both together. So they will have a new temperature. This is what we are asked to look for. So let's find this out. Now, what we'll be using to solve this question is simply the conservation of heat energy. So heat lost must be equal to heat gain. The heat lost by the hot water must be equal to the heat gained by the cold water. After all, we are to assume that what? We are to neglect heat absorbed by the surrounding. So we assume that the heat lost by the hot water is equal to the heat gained by the cold water. So heat lost by hot water is equals to heat gained by cold water. And the heat lost by hot water is given as mc theta, and also the heat gained by the cold water is also given as mc theta. Now, as we've known before that the heat gain or heat lost by substance is always mc theta. Please note that our H is equals to mc theta. M is the mass of the substance, C is the specific heat capacity, and theta is the temperature change. So our mass of hot water is 0.25 multiplied by the C of water. C is known as specific heat capacity. So our C is given as 4,200 multiplied by theta. The theta is equals to, normally it will be change in theta, which is equals to theta 2 minus theta 1. So we have our theta 2 minus theta 1. Now, okay, let me keep this equals to our mass for cold water is 0.15 kilogram multiplied by the C of water also 4,200 multiplied by theta, which is theta 2 minus theta 1. Now, when we say change in theta, what we always mean by change in is always that the difference in the two values. Let's say our theta 2 here is 5 and theta 1 here is 4, and we know that this will give us 1, right? But let's say our theta 2 here is 7. Let me clean this out. So our theta 2 here is 7 and theta 1 is 9. This give us what? -2, right? Now we don't want to have this negative. We don't want this negative. We don't want it. Now what we can do is that, because our aim is to find the changing, so it's always good for us to write the bigger one minus the smaller one. So it's not a must to be theta 2 minus theta 1. Just make sure you put the bigger one minus the smaller one so that you won't have a negative sign. Or if you still insist on doing theta 2 minus theta 1, if you will get a negative sign, you can just neglect the sign and continue your workings. So let me continue now. Now in our solution here, we realize that putting theta 2 here at this side here will make us have a negative sign here, which we don't need. But let's still go on to solve. So we're having 0.25 multiplied by 4,200 multiplied by, so then let's put our theta 1 by this side, since we know that it will be more than the theta 2, because it's the hot water is losing heat, so the final temperature will be less than 65 degrees Celsius, because it will be losing its heat to the cold water. So we're having 65 minus theta 2 equals to 0.15 multiplied by 200. Theta 2 minus theta 1 is 5 degrees Celsius. So let's do some arithmetic now. So 0.25 multiplied by 4,200 is equal to 1,050 multiplied by 65 to give us 630 multiplied by 32 minus 5. So let's go up now. So if you multiply this by 1050 multiplied by 65 to give us 68,250 minus 1050 that 2 is equals to, you open that bracket there also, you have 630 that 2 minus 630 multiplied by 5, that is 3,150. So we can collect our like terms now. We have 68,250 plus 3,150 equals 630, oh sorry, 630 theta 2 plus 1050 theta 2. So 68,250. This will give us 71,400 equals plus 1,060, 1,680. You divide both sides by 1,680. Let's cancel this. So 71,400 divided by 1,680. That's 70. So theta 2 is equals to 42.5. 42.5 degrees Celsius. And this will be all for this question. Now, let me quickly recap this. Anytime you say anything change in, like sometimes change in theta, change in length, change in area, uh, change in volume, change in velocity, anytime you see changing, it's always the bigger one, the let me say the one with the highest value, uh, subtract by the one with the lower value. So I realize most of them might be confused the way I solve this area here. Just note that it is always the what? The one with the higher value minus the one with the lower value. Is that clear? That will, so that to avoid you having a negative sign, that you won't be confused while solving. Just put, and the how I was able to know that my theta 2 will have a lower value than the theta 1 for the hot water is that I know that the hot water is losing heat and the cold water is gaining heat. Therefore, the temperature for the final temperature will be lower than the initial temperature for the hot water, while the final temperature will be higher than the initial temperature for the cool water. And that is just it. So that will be all for this question. Endeavor to like the video if you have learnt one or two things. Also subscribe to the channel if you haven't. See you again.